Okay. Uh, I. Uh, Fine. Let me see first. I. Fine. Let me see. Fine. I think we can play Not Like Us. For some reason, it's not playing. For some reason, it's not playing.
Hi, Monster on the beat, ho, Debo, any rap nigga, he a free throw. Man down, call out ambulance, tell him please, bro. Nail a nigga to the cross, he walk around like Tizo. What's up with these jabroni ass niggas tryna see Compton? The industry can hate me, fuck them all and they mama. How many options you really got? I mean, it's too many options. I'm finna pass on this body, I'm John Stockton. Monster on the beat, ho, Debo, any rap. Beat your ass and hide the Bible if God watching. Sometimes you gotta pop out and show niggas. Certified boogeyman, I'm the one that up to score with him. Walk him down whole time, I know he got some hoe in him. Pole on him, extort shit, bully the floor on him. Say Drake, I hear you like I'm young. You better not ever go to cell block 1. To any bitch that talk to him and they in love, just make sure you hide your little sister from him. They tell me Chubb's the only one that get your hand-me-downs and party at the party playing with his nose now. And Baka got a weird case, why is he around? Certified lover boys, certified pedophiles. Wop, 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 wop. That fuck em up. Wop, 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 wop. I'ma do my stuff. Why you trolling like a bitch? Ain't you tired? Tryna strike a chord and it's probably A minor. They not like us. They not like us. They not like us. They not like us, they not like us, they not like us. You think the Bay gon' let you disrespect Pop, nigga? I think that Oakland show gon' be your last stop, nigga. They cold foul, I don't know why you still pretending. What is the owl? Bird niggas and bird bitches, go. The audience not dumb, shape the stories how you want. Hey Drake, they're not slow. Rabbit hole is still deep, I can go further, I promise. Ain't that something? P-Rest stands for bitchin'. You Malibu most wanted, ain't no law boy, you ball boy, fresh Gatorade or something. Since 2009, I had this bitch jumping. You niggas will get a wedgie, be flipped over your boxes or over your foe. The other vaginal option, pussy. Nigga better straighten they posture. Got favors all up in contact. Might write this with a doctor. Tell a pop star quit hiding. Fuck a caption, won't action. No accident, I'm hands on. He fuck around, get polished. Fucked on Wayne Grower, he was in jail. That's conniving. Then get his face tatted like a bitch apologizing. I'm glad D-Rose came home, y'all didn't deserve him neither. From Alondra down to Central, nigga better not speak on Serena. And your homeboy needs subpoena. That predator moving flocks. That name gotta be registered and placed on neighborhood watch. I lean on you niggas like another line of walk. Yeah, it's all eyes on me and I'ma send it up the pot. Ay, put the wrong label on me, I'ma get them dropped. Ay, sweet chin music and I won't pass the ox. Ay, how many stocks do I really have in stock? Ay, 1, 2, 3, 4, 5 plus 5. Ay, devil is a lie, here 69 God. Ay, freaky ass niggas need to stay their ass inside. Ay, roll their ass up like a fresh pack of Zod. Ay, city is back up, it's a must, we outside. Ay. They not like us, they not like us, they not like us. They not like us, they not like us, they not like us. Once upon a time, all of us was in chains. Homie still double down, calling us some slaves. Atlanta was the mecca, building railroads and trains. Bear with me for a second, let me put y'all on game. The settlers was using town folk to make them richer. Fast forward 2024, you got the same agenda. You run to Atlanta when you need a check balance. Let me break it down for you, this the real nigga challenge. You caught Future when you didn't see the club. Hey, what? Little baby help you get your lingo up. What? 21 get your false street cred. Thug makes you feel like you a slime in your head. Hey, what? Quavo said you can be from Northside. What? 2 Chainz say you good, but he lied. You run to Atlanta when you need a few dollars. No, you not a colleague, you a fucking colonizer. The family matter and the truth of the matter. Here was God's plan to show y'all the liar. He a fan, he a fan, he a fan. He a fan, he a fan, he a freaky ass nigga, he a 69 God. Freaky ass nigga, he a 69 God. Hey, 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 run for your life. Hey, 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 run for your life. Freaky ass nigga, he a 69 God. Freaky ass nigga, he a 69 God. Hey, 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 run for your
Hi everyone, this is Vivek. Many students come up to me and ask me, Vivek, where do I study core CS from? And in general, you have a lot of theoretical resources which talks about OS, networks, DBMS and all these things. But one particular piece that I feel is missing everywhere is the initial session where everything gets connected together. Most topics start from the depth and each of the components is explained in too much of depth. Whereas what I feel should be the first thing that you learn is what are the main pieces and how they connect together, because then only you will be able to make sense. Why is OS doing this piece this way? Why is assembly language being ran this particular way in the pipeline and things like that, right? So you have compilers, COA, OS, all these subjects that pieces together to make your programs run. You have networking, DBMS to make sure that all the things that you are running on internet are kind of supported. So this is what in this live session I talked about. So I have make sure that this recording is also added on YouTube so that you can enjoy this. And in fact, I have went through like actual computers, like motherboard, right? I mean, I think many students don't even know, even after graduating from CSIT, that how does a computer actually runs. Maybe you have seen that in cyber cafes, but actually piecing them out and seeing how does actually a RAM works, or maybe just removing off, say, a core and seeing how does actual microprocessors work, what exactly their works are. Very in layman terms, but again, super important, right? So that's what you will find in this particular video. Make sure you hit the like button and enjoy the rest of the session. See you in there. Bye-bye. How does computer works? That's what we're going to talk about today. 8848, how many of you know the reference of 8848? I think somebody already wrote.
So I'll also be talking while I am watching this video. Fine. 8848 is a
Wrote in the chat.
processor.
Do you know what is the reference of 8848? No? Yes, it's Mount Everest ka height, right? It's 8848 meters. So we are going to look at how computers or
I thought it was
tech
a
realm
CPU.
works from the height of Mount Everest. Okay. And we are gonna like try and get like the clear
I thought
picture of
it
what all
is a
components
CPU.
exist. And this is, I think, one of those sessions that I wish somebody would have taken in my college to make me understand here, like how beautiful this realm
So
is.
you are from
How many of you
IIT?
have studied computer science in your college? Matlab, you had some subject, +1, -1. Matlab, you had these compiler, OSC subjects, you had these subjects in your college, +1, -1. Okay. And I expect -1 for today's class. Like what we will go through, you need zero knowledge, right? But I expect everybody to know the DSA CP we have learned. Okay? I mean, I expect you to know what is a queue, what is a like C++ code and stuff. Okay? So these all things I'll expect in the lecture. But except this, everything else I'll expect that you could learn from here itself. Okay? So today will be like more like an introductory class, and we will not like double click on anything. Yeah, how does OS works or how does network exactly works and stuff like that. But essentially connect all the dots. So it will be like outside the map and see, yeah, okay, this is a piece, and so on, right? Yeah, so many of you are not from computer science department. If you are not from computer science department, then most probably you didn't have this subject, but let's not worry about that now. Whatever we cover, that will be sufficient. So today's class will be the first class, and then we'll follow along with other things. Okay, chalo, let's start with this. So I'd love to get some perspective from you guys. Chat kare quickly. How do you think computer runs? क्या लगता है? What exactly happens behind the scene? Keyboard, mouse, you just play some keys, mouse लाते हैं, and screen पे जो चल रहा है, that is itself computers. Or there is some coding and stuff. Electricity से चल रहा है, electricity is another point I should have added in the slides, right? Coding, because there are some programs and stuff, that is why we are running it. CPU, okay, processors maybe, magic, that is also. For most non-tech people, if you go to like Indian, even cities and maybe villages, you'll realize that people don't even understand this. They just understand electricity and magic most probably, right? But you are going to be a computer scientist to some degree, not a scientist, a computer science student, if not computer science degree, but still you're going to be in software engineering. Right? So if you don't really know how computer works, I feel that's a very bad place to be in, because if you are somebody working on a certain piece of stack, there is certain things related in your industry, right? If you don't know the holy grail कि यार जिस पे काम कर रहे हैं, I mean in fact all of you guys are working on computers only, mobile or laptop. If you don't understand how that works, even some certain percentage, what kind of engineer, software engineer are you, right? So before even becoming software engineer, I think we should all appreciate here how much grateful we are for the things that we have, right? I mean, personally, I never realized these things in my college. Only when I started working, I realized, yeah, if I really need to be the best person, best software engineer in my team, right? I need to know how things are running internally. And believe me when I say this, you will realize this too after 1.5 to 2 years in your job. Yeah, shit, if I would have had read these subjects properly, maybe I would have been better at my job. Because initially it feels like it's just about writing codes, but it is not. Some people are saying कि घर वाले तो ये expect हो रहा है कि computers ठीक कर देगा. हाँ, that is what expectations have. Somebody who doesn't know tech expects. But I hope तुम्हारे expectations ऐसे नहीं है, right? How many of you? अच्छा, next question. How many of you know how real computers work? कभी देखा है computer कैसा काम दिखता है? I mean, laptop matter you know, but कभी खोल के देखा है? Yes, -1, -1.
So for context, I used to do a lot of IoT stuff, lot of Arduino, motor drivers, sensors, gyro, accelerometer, and lot of shit. So yeah, I might have a bit of idea. Though I don't know the internals of it. I used to work on drones. So yeah, let's see what it teaches.
कंप्यूटर के अंदर इतने कंप्यूटर को देखा है. You have touched a RAM, you have touched a motherboard, you have touched these things. +1 or -1? +1, nice. Okay, you are thermal memory fabric. So you guys are in a computer. Okay, let's try to do that. It's a simpler way for today. And then so I feel computers are very similar to factories, very similar to any supply chain that you might have read about. Okay, so computers are just things that like this. So yarn. Essentially, every device, every component has its own input layer and an output layer. This is the input layer. Storage is very similar in factories, right? Long-term storages, you need to store things in dark stores. So think about Blinkit, Zomato, right? So do you know from there it will quickly deliver to that? Try and understand how a program every line. So what is this? Everybody knows, right? VS Code, so be ID, right? Any code editor, basically. So you can write code and stuff. So from the place where you have a code written, let's take a very simple line of code. ये program समझ में आ रहा है before this. So you all know this command, right? G++ a.cpp, and then there is an executable created and a.out, run it, right? And it will take a name, let's suppose Vivek, and it will say print hello Vivek, right? This execution is clear to everyone, right? This is what we want to trace. Very similar to this. I will not try to do input output because they are more complicated and there's big library pieces working behind the scenes. So we'll do very simple instructions. But like, let's say there is this piece of code, and these are two commands that you are running, and it's making that code run. What exactly is going behind the scenes to make it run? Because if you can trace simpler codes, whatever complex, including this VS code that you are seeing, is also a code running behind the scenes. Does this make sense? कि अगर एक code trace हो जाए, so every other piece is also a code, isn't it? So let's try to trace this. कि more or less क्या होता है? Like, so what happens when you have a C program? Like a C++ C program are very similar. What happens when you have, and it prints a.out, it builds a.out. But there is this very nice flag -s, okay, which tells the computer, hey, I don't want to run this file. I just want to see the assembly level code that is going to be generated when this program compiles. Okay? So let's try to run this once and see how this looks. G++ -s. I want to output this in a.s, and the file that I want to run it on a.cpp. Okay? So it generates this a.s file, okay, which is assembly level code, and it is fairly large, some big piece of code. This is exactly what is going to run in computer. Okay? We'll not be able to understand this. That's why I showed you this example is much more complex. Okay? But this is essentially what the coding what happens behind the scenes. That it generates something like this, which is then sent to this like code that you are seeing. Okay? This is the work of compiler. Okay? There is this compile step which happens, which takes your code, converts it to assembly language, and then there are even more steps. Okay? So this is a statement that you can use to see the assembly level code of any particular C that will get generated. Now these are complex to read because these are machine generated and there is no purpose of a human reading it, so they are optimized for being efficient rather than being readable, right? But again, you can see them if you want. See what exactly line of instruction is going to run. Okay? little more on compilation. So if you just compile this piece of code, I mean, we can actually do that also, but I'm just making it fairly simple, right? I've just already ran it and added the screenshot on the slide. So if you run this, you will see something like this happening in the code piece. The main will be there. So we'll understand assembly level a little bit, but let's quickly like see the compilation step. What is happening? So we are saying when you have a CCPP code, okay, the first step is preprocessors that happens, right? So what happens is you have this hash defines, hash includes all these things, right? So that is the pre-processing step. Then after you have all these things added, you have compilation step. So that generates the assembly code. .s is the extension by default. Okay. So then there is assembler that basically like takes the assembly level code and makes it like actually into a binary executable. Okay. Machine code basically, machine binary bits that computers can understand. And then there is certain linking that happens based on where you are running your computer and stuff. There are
static library.
certain linking that happens. So I don't want to get into these details, but we can see this. Yes, so when you run this a.out, right, I mean, this is, you can do it, but you can generate the object files also. But this executable machine code is what we are generating over here. The machine code, okay, I can show that also. But for this piece of code, it will be so big, समझ में नहीं आएगा. तो कैसे करना है बताओ? I'll do this once after that because it will take a little. I'll show you the example also. Okay. Yeah, this is the example essentially. Okay. So assembly level code क्या होता है? This is basically still readable, still like a piece that humans can understand. Instructions definitions be given by this code जो run करना है. But then that gets converted to a machine level. It will look something like this. This is an hexadecimal like stream. It's like just a stream of instructions. This is the machine byte code that will be generated, and then it will be sent into the core in the stream format. Okay, so I can generate a little. This is what you see. You'll never need to generate this because this is not human understandable. So this is essentially the function, or like assembly level language. This is the function actually. But this is how the machine level code would look like once you do the translation, this assemble step, okay? And then a little bit translation into how exactly on your computer which memory locations will be used for this particular program and stuff like that. Once those things are added, you have the final executable. That exactly this memory location needs to be used when you are like using this variable and stuff like that. Okay, so that's what happens. So let's try to understand a little bit on what this assembly level code looks like. It looks very weird, but it's understandable. I'll show you how it is understandable, right? Let me see if I can draw on the screen, right? So let's try to see what happens. There's this x equal to 5 wala line, right? It's pretty scary. That's not true. Once you understand it, it's super simple. This is just another language. Languages might be scary because nobody designed it in a way that it should be read by human. But I think it's really interesting. Once you understand it, it's super interesting. So this looks scary. It's not scary. Because when you started learning C++, it might have been scary. But is it really scary once you understood it? Not really, no. So see, there is something 5 being stored in X, right? So there is this main program that is starting. There is stack pointer. We will read about what is stack pointers and stuff when we do OS, how does programs get run in memory. But see, move 5 into W8. What does this mean? Give 5 safe for W8, isn't it? So something like this is kind of happening. Add 2. See, whatever the value that you stored over here, store the value in stack pointer plus 12 sort of thing. Then add what in the W8. So this is X over here. So this is W8 over here. Okay, X is containing W8 is like a variable which stores the value of X. Plus 2 will be stored in W8. Okay, and it is being used as a temporary variable for Y also. Okay, or you can say that it's being stored in the local variable. There is the stack. Okay, so stack pointer plus 8. This is stack pointer. Stack pointer 8 के बाद 4 space में you are storing Y. ठीक है, so store in the stack pointer plus Y the W8 value which you calculated over here. इधर भी क्या किया था stack pointer plus 12. Stack pointer plus 12. उस पे स्टोर किया था हमने x वाला वैल्यू, फिर x वाला वैल्यू को स्टोर किया, फिर उसको वापस लोड किया W8 पे एंड उस पे +2 करके उसको y में स्टोर कर दिया. Did you get the idea क्या हुआ इसमें? See, stack pointer एक मेमोरी लोकेशन, suppose RAM में एक मेमोरी होता है ना, मेमोरी लोकेशन. We know that 4 bytes करके, like you have 4 bytes का इंटीजर में like space, right? So जो stack हम लोग बोलते हैं stack create होता है जब function call होता है. So this is the stack of the function call of the main. उस पे 16 का कुछ space उसने बना दिया, फिर 16 का उसमें space है, ठीक है? Stack pointer plus 16 कर देगा. So what it is saying, create a variable W8 जिसमें 5 स्टोर हो रहा है अभी, 5 is the value, ठीक है? 12 is the value, these are values. And then it is being added, this is being moved to W8. W8 करके एक variable है जिसमें पहले 5 स्टोर हुआ. Now store in stack pointer plus 12, stack pointer plus 12 वाला जो लोकेशन है उस पे 5 स्टोर करो. So x equal to 5. This is what is storing the value x. Then load the value that is stored in x in a variable. It is reusing this variable as again loading the 5 from here to here. Then it is adding +2 to this, so it becomes 7. Now this is what it is saying is store it to stack pointer plus 8. So it is being, this location is being used as the variable y, local variable y. ठीक है? And then move like this is other parts of the code. We don't need to understand ये कैसे काम कर रहा है. This is like reverting the things कि अभी हम लोग इस phase में हैं, main खत्म हो गया, वापस stack pointer जो subtract किया उसको revert कर लो and then return from the function. Sort of that, all those things happen. Okay. But more or less कुछ तो connection है, like some connection is there, right? हमें assembly language सीखना नहीं है. We don't need to learn assembly language. But थोड़ा connection समझना है कि there is this move variable, store variable, load variable, add, store, move, add. These are load register, load into register. So these are, I generated this in MacBook. So there are the constructor. This is AMD processor, right? So AMD uses a different set of instructions over here. जैसे हम लोग जो i7, i5, i3 देखते हो, these are x86 processors, ठीक है? उस पे थोड़े instructions अलग होते हैं. So we'll talk about this in the next class. RISC करके कुछ term होता है. We'll talk about. Complex term है, concept simple है, कुछ है नहीं, ठीक है? Terms बहुत बड़े-बड़े हैं, ठीक है? काम बहुत simple है. कुछ नहीं बस stack में pointer आगे पीछे move कर रहा है उसका values. How does compute? तो टाइम नहीं मिल रहा है, things like this, right? So this is what the problems are. Printing to the a C++ code, let's say, written some. How will it know which one to send? Okay, where do you want to send? Okay. API it's just running somehow. Whereas the actual hardware, the like detail has been already been figured out by other folks. Okay. So if you had to solve this from end to end, like you would need years, order of years to solve those problems. So we live in a world of abstraction. Everything has been abstracted out for us. We just need to write the computers that you are running.